Good afternoon to all. Myself and Arun Kumar from EC department. In this video, we are going to see block diagram reduction techniques in control system modeling functions. So one of the important parameters in control system modeling function is block diagram reduction techniques because it is the factor which can reduce the number of blocks in the control system modeling functions. Because whenever we are going to transfer the data or information to the destination, we have to check whether the all the system transfer function is correct or not. Some of the system transfer function may not be forwarded to the destination due to the illness of the concern control system functions. So in order to eliminate all those function, we can use this block diagram reduction techniques. Here, some of the rules are followed to control the informations. So here we are going to see how the block diagram reduction rules has been enabled in the block diagram reduction techniques. So there are some three factors which is used to identify the control system transfer functions, either input or output or transfer functions. Based on the three terminals only, we can able to eliminate or transfer the information from one to another. So in order to transfer the information, we need to check whether the function, the transfer function is it is in a it is in correct way or wrong. By using this summing point or takeaway point, takeoff point, we can add or eliminate the transfer functions. So it can be followed by the rules and regulation of the block diagram reduction techniques. So first one is summing point. In order to add or eliminate the more number of points, we can use this summing point rule, a and b, a minus b, because here it is minus, it is plus. So we can add or eliminate the concern summing point. Next one is the combining blocks in cascade. If it is in cascade mode, the transfer function is in cascade mode, then the path can be eliminated by z1 into 0. If it is in cascade mode, you can choose this rule and you can implement the transfer function by z1 into z2. And combining the parallel blocks, if the blocks are in parallel, if it is in parallel to the summing point means, then we can use this rule. Then the transfer function can be eliminated by z1 plus z2. If it is in parallel, then automatically the blocks are removed and it can be forwarded by only one block, z1 plus z2. Next one is moving a branch point ahead of the block. So branch point is x1. If it is moved towards the transfer function of the g1. So it can be followed by using this rule by x1 z1 towards the summing point, toward ahead of the block g1 by 1 by 0, because it is moved towards the other end, so that we can use it as 1 by 0. And next one is moving a branch point before the block. So moving the branch point before the block, the same example we have discussed in the previous, the same will be followed here, but the condition is it can be moved towards the block of g1. So it can be followed by z1, because it is moved towards the g1. So 1 by z1 will be eliminated into z1, because it's a z1. If it is moved towards after the block z1 means, then automatically it will comes 1 by z. Like that it will be followed in this rule. And next one is moving the summing point ahead of the block. The summing point is plus and minus, the summing point and ahead of the block g. So the summing point can be moved towards the block, can be followed by the summing point can be moved towards the block. After that it can be added g, because it is forwarded from block z only. So automatically the additional point z1 can be added in the summing point. Next one is moving the summing point before the block. Moving the summing point before the block z. Moving the summing point before the block z. After alternatively it will be followed by the summing point, because in previous rule it can be followed by z, because the loop is connected in the nearby block g. So the same will be followed in this next principle also. It can be followed by the same point, the 1 by z will come towards the after the block g1. and this is the one of the important rule which is followed in the block time reduction techniques, because even though if you want to transmit more number of blocks in a single source means, this kind of elimination rule will be followed, because whenever we can transmit the information to the concerned destination block, sometime the blocks are followed in between the loops, so that kind of loops can be eliminated by using this rule. So it can be eliminated by Z and H. H can be connected by summing point as well as the branch point. It can be eliminated by using this rule. It can be followed by Z by 1 plus or minus ZH, because plus or minus G into H. G into H. G is the point. It can be connected to the feedback point H. So G into H. So G by 1 plus or minus Z into H. It can be very useful to transfer the large number of block diagram techniques. So one of the assessment which is shown in this PPT is G1, G2, Z2, Z3, Z4. The based on the previous rules, we can implement it here one by one by one. One of the rule which is used to eliminate is feedback loop, and as well as the parallel block and summing point. These are the rules has been implemented in this block diagram reduction techniques. And the rules after the elimination of the blocks, the final solution of the concerned block diagram reduction is Z4 plus G2 and G3. These are the two laws or rules are implemented in this block diagram. Apply the rule of moving pickup for takeoff point, because it is also a feedback loop, and moving summing point based on this first rule we can eliminate, and the second one is eliminate the loop after the branch point elimination. We can eliminate the entire loop by using the previous rules. After finding all those rules, we can have a G4 plus G2 and G3. So these are all some of the examples while considering a block diagram reduction techniques. Thank you.